कहले ये दूसरा
Good morning, everyone.
Morning, ma'am.
Morning. Have all of you got your credentials regarding form filling? Have all of you got it? Mukund hasn't got it, that I know. And rest, what about the rest? All of you have got it?
Yes, ma'am. Yes, ma'am.
Okay. Mukund, are you there, Mukund? Mukund, are you there? Mukund hasn't joined till now, no?
ম্যাম
Yes.
আমি বলছি ফর্ম ফিল আপের ওই জায়গাটা তো ব্ল্যাঙ্ক আসছে, কিছুই আসছে না।
কিছু আসছে না?
मैम वी
না
नीड
না
टू सबमिट द एग्जामिनेशन फॉर्म मतलब कैन आई से मैम
Yeah, obviously.
दो मैम जो पर्सन ही वाज आस्किंग हम लोग को इफ यू आर हियरिंग हम लोग को एग्जामिनेशन फॉर्म में जाना है और नीचे लेफ्ट हैंड
अच्छा
साइड में एक चेक बॉक्स है उस पर क्लिक करके सबमिट फॉर्म कर देना है फिर वहां से कॉलेज वेरीफाई करेगा फिर वी नीड टू प्रिंट इट आउट और साइन करके फिर से उसको स्कैन करके एक ईमेल आईडी दिया है एग्जामिनेशन सेल का वहां पे अपलोड करना है विथ पेमेंट स्टेटस
আচ্ছা 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 থ্যাংক ইউ সো মাচ মুকুল মুকুল তুমি শুনলে রাহুল কি বললো?
ইয়েস ম্যাম।
হ্যাঁ ঠিক আছে ওই প্রসেস তাহলে ফলো করো। থ্যাঙ্কস আ লট রাহুল।
थैंक यू मैम
আচ্ছা tell me something, what about your syllabus? I mean chemistry. What about the syllabus of chemistry?
ফার্স্ট সেমিস্টারে তো এখনো বলেনি ম্যাম, ম্যাথটাই খালি জানি আপনি দিয়েছেন।
আচ্ছা আচ্ছা কেমিস্ট্রি তো হলো, আর ইয়ে সুমিত স্যারের কতটা বাকি আছে কম্পিউটার?
স্ট্রিম চলছে, স্ট্রিমের পর মনে হচ্ছে
মানে আমি জানতে চাইছি what percentage is left, Shumit sir or chemistry, what percentage is left? In maths we are only left with the three vector theorems, Green's theorem, Stokes theorem and Gauss theorem. We are left with these three theorems. I'll start with Green's theorem today. এরকম আমি জানতে চাইছি সুমিত স্যারের কি স্ট্যাটাস আর ইয়ের কেমিস্ট্রির, and Ashish sir also English. What's the status of English? English you are having only lab class, so what is the status, present status? हाँ सौरभ कुछ कह रहे हो?
Yes, ma'am.
Yes सौरभ, yes.
Ma'am, Group B এর অনেক মাত্র only 2 classes হয়েছে।
In English?
Yes,
English?
Yes.
Okay. Okay, and what about Group A? English, what about Group A? Ashish sir takes the class of Group A also, na? He's in charge of Group A also, isn't
Yes,
it?
ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
So
Yes,
what
sir.
about Group A? What about Group A? Siddharth, you are from Group A or what?
Yes, ma'am. Group A.
Group A, how many classes sir has taken?
5, 6.
5 to 6. Okay. Okay, English, as far as I know, in lab, he takes, sir or ma'am takes 5 or 6 classes, as far as I know. So, I think group A is almost complete. I think so. That's only my assumption. I may be wrong, but group B तो काफी बाकी है फिर. Now, what about chemistry practical? What about chemistry practical? Do you know the syllabus of chemistry practical?
We are up to experiment number 6.
Acha, 6, experiment number 6. How many experiments are there? 7 or what? Is it 7 or 8?
8 ম্যাম,
Or
8
6?
মানে
8.
গ্রুপ
আচ্ছা,
এর
আচ্ছা।
ম্যাম এক্সপেরিমেন্ট 7টা হয়েছে শুধু, আর ওদের ওদের হচ্ছে এক্সপেরিমেন্ট 6 হয়েছে।
6, আচ্ছা। তো ঠিক আছে, কেমিস্ট্রি প্র্যাকটিক্যাল তাহলে হলো, মোটামুটি এক্সপেক্ট করতে পারি আমি জানুয়ারিতে শেষ হয়ে যাবে। আর সুমিত স্যার, হোয়াট অ্যাবাউট সুমিত স্যার? প্র্যাকটিক্যাল ল্যাব? Okay, and what about theory? Shumit sir's theory?
Up to functions. He's still carrying with functions.
That I won't understand. Na? I mean to say, how much is left?
দুটো চ্যাপ্টার বাকি।
দুটো চ্যাপ্টার বাকি আছে, আচ্ছা। Out of কত? Out of what? Out of কত গো?
21
Out of
21
21। আচ্ছা, 21 এর মধ্যে দুটো বাকি আছে। 21 আমি ঠিক শুনলাম? ঠিক বলছি আমি?
Right.
ওকে, তো ঠিক আছে, more or less. Okay. Anyway, so that means we can expect that your syllabus will be completed by the end of January. That we can expect. I think so. Okay. So today we are going to start the vector theorems. There is Green's theorem, Gauss theorem, and Stokes theorem. Green's theorem is a relation between line integral and double integral. Then after that, we'll be studying Gauss theorem. Gauss theorem is also known as Gauss divergence theorem. Divergence theorem, that's a relation between double integral and triple integral. And after that, we'll study Stokes theorem. Stokes theorem is a relation between, again, line and double integral. So we'll start with Green's theorem. Green's theorem. Suppose P and Q be any two functions of x and y. Green's theorem, as I told you, is a relation between line and double integral. So suppose P and Q are two functions of x and y. The functions are such that P, Q, del P, del y, and del Q, del x. These are all continuous in a region R of xy plane, bounded by a simple closed curve gamma. Now, what do you mean by simple closed curve? Closed curve, obviously, you know the meaning of closed curve. What do you mean by closed curve? What do you mean by closed curve? What is a closed curve? What is an open curve? What do you mean by open curve and what do you mean by closed curve? You all know it. Closed curve and open curve, please tell me. What's the difference between closed curve and open curve? You all know it. Closed curve, open curve. Please tell me, anyone, please tell me, what do you mean by open curve and what do you mean by closed curve? Please tell me, closed curve and open curve.
Ma'am,
Yes.
open curve has no area that it has, but according to a closed curve, it has an area, and we can
Okay, it
calculate that area.
encloses an area. Okay.
Yeah,
Okay,
exactly.
okay. So that means, yeah. So that means closed curve is what? Suppose we are closed curve means, suppose we are starting from a point A and we are coming back to the point A. That is called closed curve. That's called closed path. We are starting from a point and we are reaching at that particular point. That is called closed curve. And that means closed curve encloses certain area. But open curve means the starting and end points are different. Suppose we are if you draw like O, if you draw O, a circle, simply if you draw a circle, we are starting from a point and we are coming back to that point. That is called closed path. That is called closed curve. And if we draw a half circle, starting and end points are different. In that case, we call it an open curve. So what Krishna Kishore said is perfectly all right. That means closed curve, when we are considering a closed curve, it encloses certain area. But if we consider an open curve, it doesn't contain any area. It doesn't have an area. Okay. So now, and simple, the word simple means the curve doesn't intersect itself at any point in between. That means, suppose we are considering a circle. This is a simple curve. The curve, simple curve means the curve should not intersect itself at any point in between the endpoints. If we draw 8, if we draw a curve like 8, then this curve is, just a minute. Just a minute. If we draw a curve like 8, then that curve is intersecting at this point. Starting point is, suppose we are starting from the topmost point and we are doing like this. Again, we are coming back to this point, but in between the starting point and end point, there is a point where the curve is cutting itself, where the curve is intersecting itself. That shouldn't happen. In case of a simple curve, that shouldn't happen. So simple curve is simply like this, a circle or an ellipse or anything simple. It should not intersect itself at some point in between the endpoints. So suppose we are having a closed region R in XY plane, which is bounded by a simple closed curve. This is the symbol for capital gamma. This we call capital gamma. And P and Q, these are two functions of X and Y. The functions are such that PQ, del P del Y and del Q del X. These are all continuous functions over the region capital R. In that case, if we consider the line integral of P dx plus Q dy over that boundary gamma, that will be equal to double integral over R del Q del X minus del P del Y dx dy. Okay, where gamma is traversed in anti-clockwise sense. Mukund, can you hear me, Mukund?
Yes, ma'am.
Have you got the credentials?
Yes, ma'am.
Okay, thank you. Okay, so suppose PQ, del P del Y and del Q del X, these are continuous functions over a region capital R of XY plane, where gamma is the boundary of that region R and gamma is a simple closed curve. In that case, the line integral over gamma of P dx plus Q dy, that is equal to the double integral over R del Q del X minus del P del Y dx dy, provided gamma is traversed in anti-clockwise sense. If that sense was clockwise, in that case, this would have been minus of this. So line integral of P dx plus Q dy over the boundary, that is equal to double integral over the region R of del Q del X minus del P del Y. In some books, these are written as M and N. Instead of P and Q, they use M and N. So from this topic, two types of questions come. One is of 5 marks, another one is of 8 marks. 5 marks question is evaluate this integral by Green's theorem, by using Green's theorem. Evaluate this. Some line integral will be given to you and the question will be evaluate this using Green's theorem. That means we'll have to convert it into the corresponding double integral and find the value of it. That type of question carries 5 marks. And another type of question is there, which is verify Green's theorem for this integration along this, for this region. So there, in that case, that type of question carries 8 marks. 4 plus 4, you will have to consider, you will have to show the line integral as well as the double integral and verify that these two are equal. So both the integral will carry 4 marks. 4 plus 4, total marks will be 8. A vector field F is given by F equal to sin y I plus x into 1 plus cos y j. Sin y I plus x into 1 plus cos y j. Evaluate the line integral integration over gamma f dot dr, where gamma is the circular path given by x square plus y square equal to a square. Gamma is the circular path given by x square plus y square equal to a square. F is sin yi plus x into 1 plus cos y j. Question is evaluate using Green's theorem. So integration over gamma f dot dr. Integration over gamma f dot dr. That will be equal to r is position vector. R means x plus iy. Position vector of a particle, that is x plus iy. So obviously your dr will be dxi plus dyj. So f dot dr, that is sin yi plus x into 1 plus cos yj dot dr. Dr means dxi plus dyj. I dot I is 1, j dot j is 1, I dot j is 0, j dot I is 0. That's why this will be sin y dx plus x into 1 plus cos y dy. Integration over gamma sin y dx plus x into 1 plus cos y dy. This is your p dx plus q dy. That is p dx plus q dy. Now integration over boundary p dx plus q dy, that will be equal to double integral over r del q del x minus del p del y. Del q del x minus del p del y dx dy. So del q del x, that means del x of x into 1 plus cos y minus del p del y, that is del y of sin y dx dy. Now del x of x into cos y. Del x of this will be 1 plus cos y. And del y of sin y, that will be simply cos y. So this is 1 plus cos y minus cos y. Cos y cancels out. There is 1 integration of 1 dx dy. That is simply integration over r, double integral over r dx dy. Now that means what? It was a circle. The given equation was a circle, x square plus y square equal to a square. So double integral over r dx dy is simply the area of the circle, and that will be equal to pi a square. এইভাবে যদি না করতে চাও কোনো প্রবলেম নেই, double integral over r dx dy. The region was x square plus y square equal to a square. That means y square is a square minus a square, a square minus x square. So y is plus minus root under a square minus x square. So here y will vary from minus root under a square minus x square to root under a square minus x square. Minus root under a square minus x square to root under a square minus x square. So that will be equal to twice 0 to root under a square minus x square. That is the limit of y. Then for limit of x, we are having x square equal to a square. So x equal to plus minus a. So x will vary from minus a to plus a. So x from minus a to plus a, y from minus root under a square minus x square to root under a square minus x square dx dy. Integrand is 1. So that will give you pi into a square. After integration, you will get pi into a square. Okay. Now this one, verify. That was evaluate using Green's theorem. Now this is verify Green's theorem for closed integral over C, xy plus y square dx plus x square dy, where C is the closed curve of the region bounded by the line y equal to x and the curve y equal to x square. Verify Green's theorem for this, C being the closed curve of the region bounded by y equal to x and y equal to x square. So we have our Green's theorem, closed integral over C, line integral p dx plus q dy, that is equal to double integral over r del q del x minus del p del y dx dy. Now the integration is xy plus y square dx plus x square dy. Xy plus y square dx. So p is your xy plus y square and q is your x square. P is xy plus y square and q is x square. So this first let us find out the double integral, find out the line integral portion. So this will be, C is closed curve of region bounded by y equal to x. The line is y equal to x and the curve is y equal to x square. First, let us find out the points of intersection. Obviously, the points of intersection will be 0, 0 and 1, 1. O is 0, 0 origin and A is 1, 1. Now, the curve should be traversed in anti-clockwise sense. So this curve, this closed curve is comprising of the straight line y equal to x, that is denoted by C2, and the curve parabola y equal to x square, that is denoted by C1. Since the direction should be anti-clockwise, therefore, while moving along C1, we should start from O, we should reach at A, and while moving along C2, we should start from A, reach at the point O. Because the orientation should be anti-clockwise. If that was in clockwise sense, then C1 would have been this, A to O, and C2 would have been this, O to A. But this is, C1 is from O to A, then C2 is from A to O. So the total integration, line integration is equal to line integration over C1 plus line integration over C2. That is equal to, while we are moving along C1, we should put y equal to x square and dy equal to 2x dx, and limit of x will be from 0 to 1. And while moving along C2, we should put y equal to x. Therefore, dy will be dx, and range of x will be from 1 to 0. Okay. So the first one is along C1. C1 means this one, y equal to x square. So this will be y equal to x square. Therefore, this will be p dx plus q dy. P is xy plus y square dx, xy plus y square. So ax into x square plus y square means x to the power 4 dx plus x square into dy. dy will be 2x dx. So x square into 2x dx. That is along the first path, that is your C1. That will be equal to, they have to work it out separately, okay. And the next one, C2. C2 is along y equal to x. So we'll replace y by x, and therefore dy will be replaced by dx. And x will vary from 1 to 0. So this will be x into x plus x squared dx plus x squared dx, where x is varying from 1 to 0. Okay. Ultimately, we'll get after integration, just a minute. We're getting the result will be equal to minus of 1 by 20. This is for the line integral portion. Now we have to consider the double integral portion. For double integral, we need to find out del q del x and del p del y. P is what? P is our, just a minute, P was what? P was xy plus y square and Q was x square. So first we have to find out del Q del x and del P del y. Del Q del x and del P del y. Then we'll subtract one from the other one. Now del Q del x. Del Q del x will be what? Q is x square. So del Q del x will be 2x. And del P del y. Del P del y, P is your xy plus y square. Therefore, del P del y will be ax plus 2 into y. So the double integral will be equal to del Q del x minus del P del y. That is 2x minus del P del y means x plus 2y. So 2x minus x minus 2y. That means x minus 2y. The integrand is your x minus 2y. This is x minus 2y. Now, what are the limits of x and y? The points of intersections are 0, 0 to 1, 1. So, let us first integrate with respect to y. Then we'll draw a line parallel to y-axis. We draw a line parallel to y-axis at the lowest point of it, at the bottommost point of that line. That point is on the curve y equal to x square. Bottommost point is on the curve, on the parabola y equal to x square. So therefore, at that point, y will be replaced by x square. And at the topmost point of it, which is on the straight line y equal to x, at the topmost point, y will be replaced by x. So y is varying from x square to x. And then x varies from leftmost point to the rightmost point. Leftmost point, at the leftmost point, value of x is 0. At the rightmost point, value of x is 1. So x is varying from 0 to 1. So if y will vary from x squared to x, then x will vary from 0 to 1. Just a minute. Just a minute. Excuse me. Please excuse me. Excuse me. So, therefore, now if we first integrate with respect to y, then we'll have to draw a line parallel to y-axis. At the bottommost point of it, that point is on the curve C1, there's y equal to x square. So y will be replaced by x square there. And at the topmost point, which is on the straight line y equal to x, there y will be replaced by x. Therefore, y will vary from x square to x. Then x will vary from the leftmost point, which is your 0, 0. There is x equal to 0 to the rightmost point, which is x equal to 1. Therefore, x will vary from 0 to 1. So y is varying from x square to x, then x varies from 0 to 1. This is the double integral. These are the limits of the double integral. Just a minute. So this will be your, that will be equal to 0 to 1 x to the, this is 0 to 1 xy minus y square from y equal to x square to y equal to x dx. Then after this integration, we'll be getting x square minus x cube plus x to the power 4 between 0 and 1. So again, we'll integrate it and we'll get x to the power 5 by 5 minus x to the power 4 by 4 between 0 and 1. That is equal to minus 1 by 20. So line integral is equal to minus 1 by 20, which is same as the double integral. Therefore, this in this way Green's theorem is verified. So this type of question carries 8 marks. 4 marks will be allotted for each of these two integrations. And if the question is simply evaluate using Green's theorem, that will carry 5 marks. For example, let's consider this one. Evaluate by Green's theorem. Have you got it? Last problem, is it clear to all of you? Have you understood it? Have you understood?
Yes, ma'am.
Okay. Okay. Now this one, evaluate by Green's theorem. Closed integral over C, cos x sin y minus xy dx plus sin x cos y dy, where C is the circle x square plus y square equal to 1. Okay, evaluate by Green's theorem. So line integral is given. That means we'll convert it into double integral and we'll find out the value of that integral. That's what we have to do. Okay, so first we have to mention P equal to this and Q equal to this. So what is P? P is your cos x sin y minus xy. That is your P. And Q is your sin x cos y. Okay, so this integral is of the form P dx plus Q dy. So we'll convert it into the corresponding double integral. That means double integral over R del Q del x minus del P del y. So what will be del Q del x? Del Q del x means del x of this thing. That is del x of sin x into cos y. So that will be cos y into cos x. Minus del y of this. Del y of this is what? Cos x into cos y minus x. So that will be, this will be equal to cos x cos y minus cos x cos y plus x. So integrand is only x. X dx dy, double integral, and range of x and range of y. So the circle is, the region is the circle x square plus y square equal to 1. So if we first want to integrate with respect to y, in that case, we'll draw a line parallel to y-axis. At the bottommost point, y square is equal to 1 minus x square. So y equal to minus root under 1 minus x square. At the topmost point, y equal to plus root under 1 minus x square. Y is varying from minus root under 1 minus x square to plus root under 1 minus x square. That is y. And then x is lying between x কোথায় থেকে কোথায় যাবে? The circle is x square plus y square equal to 1. তো x এর লিমিট যখন দেব, y কে ছেড়ে দেব, x square equal to 1. We'll consider only the equation x square equal to 1. That is, and এমনিতেও জানো তোমরা x square plus y square equal to 1. That's a circle with center at origin and of radius 1. So the rightmost point is your 1, 0, leftmost point is minus 1, 0, topmost point is 0, 1, lowestmost point is 0, minus 1. Huh? So we'll consider the leftmost point is minus 1, 0. So x is varying and the rightmost point is 1, 0. So x is varying from minus 1 to plus 1. Okay. So y is varying from minus root under 1 minus x square to plus root under 1 minus x square, and x is varying from minus 1 to plus 1. So this is minus 1 to plus 1. If we first integrate with respect to y, integrand is 1. If we want to integrate first with respect to y, then the integrand is 1. 1 means After integration, that will give you y. Y means this minus of this. That is 2 into root under 1 minus x square. And x is varying from -1 to +1. So the function is ax into root under 1 minus x square. We'll have to integrate it, but just see, ax into root under 1 minus x square, that is an odd function. Because 1 minus x square, that function is even. Ax is odd. So if we multiply it, acha, ami je eto odd even boli, the concept of odd function and even function, is it clear to all of you? Do you mean by what do you mean by odd function? What do you mean by even function? And what's the advantage of that? কেন আমি ইন্টিগ্রেশন করার সময় মাঝে মধ্যে এই অড ফাংশন ইভেন ফাংশন এই কথাগুলো ইউজ করি বলো তো কেন what's the advantage of that? First of all, tell me, what do you mean by odd function? What do you mean by even function? Anyone please respond? What do you mean by odd function? What do you mean by even function? For this particular problem, it's not that you have to use that concept. It's not like that. You simply integrate the function and you'll get the answer. It's not that you have to use that concept, but sometimes if you use this concept, the things becomes, the integration process becomes easier. Integration becomes much more easier. Time অনেক কম লাগে ওই কনসেপ্টটা ইউজ করলে। তো what do you mean by odd function? What do you mean by even function? রিয়াঙ্কা একটু বলবে? Riyanka, will you please tell me what do you mean by even function and what do you mean by odd function? Riyanka, can you hear me? Okay, anyone else?
Miss, in an odd function, if we replace the value of x is minus x, the value of the function is now minus fx. But in an even function,
Okay.
fx is equal to f minus x.
Exactly. So, in case of an odd function, suppose the function is denoted by f of x, then if we replace x by minus x, then in case of an odd function, the functional value will, that means f of minus x will be equal to minus of fx in case of an odd function. But if you consider an even function, f of minus x is same as f of x. For example, if you consider x square, it's an example of even function because if you replace x by minus x, it remains x square. But if you consider only the function x cube, then if you replace x by minus x, the f of minus x will be minus of x cube. Minus x whole cube, that is equal to minus x cube. Minus x cube means minus of fx. So the functional value remains the same, but the sign changes. That is called odd function. Whereas if the changing of when we change the sign of x, the sign of fx doesn't change. If x remains the same, then that's called an even function. What's the advantage of taking help of, why do we take help of even function, the properties of even function or concept of even function? Krishna Kishore, why do we take help of those properties, even properties of even function or odd function? What's the advantage of that? Krishna Kishore?
Ma'am, the advantage of using even and odd function is
while in integration, আমি সবসময় ইন্টিগ্রেশন করার সময় কেন বলি this is an odd function, আর কোথাও তো বলি না কথাটা। ইন্টিগ্রেশনের সময় sometimes I use that word, this is an odd function, so this is equal to this, since this is an even function, therefore this is equal to this. Why I say that? While doing integration only, why I use this concept, why I prefer to use this concept. বলো, বলতে পারবে, বলো।
means because the even function gives a symmetrical thing.
Okay. An odd function, for an odd function, it's, since it is not symmetrical one, therefore for odd function, minus a to plus a integration is equal to 0. That's the advantage of using this concept of odd function. Okay, if we have to integrate a function between minus a and plus a, minus alpha plus alpha, minus pi plus pi, minus minus 1 to plus 1, etc. If we integrate a function between minus 1 and plus 1, if it is an odd function, the result will be 0. If it is an even function, that will be twice integration 0 to 1. Is that clear? Is it clear?
Yes, ma'am.
Okay. Okay. So, can you hear me? Can you hear me?
Yes, ma'am.
Okay. So here we are having x into root under 1 minus x square. Now 1 minus x square, that is an example of an even function, whereas x is an odd function. And if we multiply an odd function by an even function, obviously the result will be odd. So x into root under 1 minus x square, this is an odd function. And the limits of integration are -1 to +1. So obviously, if we integrate this function between -1 and +1, since it is an odd function, the result will be equal to 0. Once again, I'm telling you, it's not that you have to use this concept here. It's not that without taking help of this, you cannot do it. It's not like that. Simply put x equal to sine theta, then this will be your sine theta. This will be root under 1 minus sine square theta. There's cos theta, and there's sine theta into cos theta. It will be d of sine theta. There is cos theta. So cos theta d theta. That is becoming cos square theta. So you can integrate it or directly directly korte paro. You know the formula for x into root under 1 minus x square integration, and you can do it directly also. Okay. Acha, please leave the class and join once again. Please leave the class. Time is over. Leave the class.
বিটওয়াইজ অ্যান্ড আর বিটওয়াইজ অরের মধ্যে পার্থক্যটা আমরা পড়ছিলাম, তাই তো?
Roll number 1,
Yes, ma'am.
2,
Present, ma'am.
3. Roll 3.
Present, ma'am. Present, ma'am.
4. Okay.
Present,
4,
ma'am. Present, ma'am.
5. Okay, 5. Roll number 5. 6,
Yes, ma'am.
7,
Present, ma'am.
8,
Present, ma'am.
9, 10,
Yes, ma'am.
11,
Present, ma'am.
12, 13, 13. He was present in the last class. I think so. Yes, he was present. 14.